Hey everyone, as part of the Azure Spring Clean 2024 event, we're going to discuss network troubleshooting with Azure Network Monitoring tools and take a look at what we can do. Let's proceed. So before we go any further, let's just take a look at the cost of what a network outage could be. So this is information taken from Gartner. So on average, network outages cost 33% of firms over $1 million a year of lost revenue. Recovery time for network based incidents is on average 119 minutes. 238 minutes is the downtime duration. So although it may be 119 minutes to recover, the actual downtime based on actually alerting, finding it out, going through the process, the impact to the users, 238 minutes average downtime. So for SMB, so small, medium businesses, the downtime impact is 117K, and obviously enterprises is a lot more at 250K an hour to 300K an hour for businesses. So as you can see, the cost of a network outage is very high.
High, so being able to reduce the overall impact of network jibber and in some cases prevent is key, and we can use some of the tools provided by Microsoft in the Azure Toolkit to do just that.
So let's take a look at the Azure Network Watcher portfolio. So this is a portfolio of services and systems offered by Microsoft to assist you in your network monitoring and maintenance. So we have Network Insights, which is the metrics. It offers a topology view, health and alerts across your entire Azure networking estate, including on-premises capabilities for on-premises anywhere. We'll talk about a bit about that with Connection Monitor. So Connection Monitor is part of the Azure Network Watcher portfolio. It allows you to set up connections between one endpoint and another and monitor it. So that endpoint could be an Azure Arc agent that's connected on-prem, trying to communicate to a resource that's in Azure. So you can use the Connection Monitor to do that as well. Network troubleshooting diagnostic tools. So imagine you're running an Azure networking infrastructure and you're monitoring the connection with Connection Monitor, and all of a sudden that goes down. You get an alert and you can see red in the dashboards. That's when you'll go into the troubleshooting diagnostic tools. So we have the ability to packet capture. So we can packet capture between virtual networks and between a VPN gateway as well. We can do IP flow verify. So what's the flow of one IP address connecting to another? That lines up with the next hop. So if you're doing route-based testing or troubleshooting as well, what is the next hop of this IP address going to this one? Where is it going? Is routing effective or relevant? Effective security rules is another one. So what are the effective rules? Is RDP getting blocked? Is it allowed? Being able to see it all in one place helps troubleshoot. And of course, VPN troubleshoot, where it will go through an automated response and troubleshooting to go and have a look at those gateways. Is it up or down? All of this is underpinned by the traffic analytics and NSG flow logs to really give you that extra level of detail around what is happening within your Azure infrastructure and networking components. So we'll just recap here. So we've got our monitoring components, so the network insights, the topology, the health and alerts. We've got our connectivity monitoring using Connection Monitor, and we've got our traffic recording and analytics using NSG flow logs, so network security group, flow logs, and traffic analytics. And then we've got our troubleshooting tools, so packet capture, IP flow verify, next hop, effective security rules, and VPN troubleshoot. As you can see, it's not just elements of Azure as well. So, connectivity monitoring is really useful when you're troubleshooting connection from on-premises into Azure, but we'll go through a demo of that shortly. So let's discuss and have a look at the lab that I've got. So we're going to go through a demo to really understand and have a look at some of these tools at a very high level and what it can give you. In order to do that, I've got an environment. So I've got a simulation of an on-premises VNet that's in the France Central region. And then I've got a hub and spoke model in West Europe, and then a hub and spoke model in North Europe region as well. So in order to do this, I'm using Nicola's, which is Microsoft Cloud Solution Architect in Italy. He's a virtual WAN playground. So it's just a hub and spoke playground. You can grab it directly off GitHub. I'll put the link in the video chat. But that's being able to automatically create this environment for me. And this is exactly what I've got within my Azure subscription and what we will be having a look at. I've also used Azure Policy. So when you start delving into troubleshooting virtual networks within Microsoft Azure, one of the things that's very key is really your network security group flow logs. So you've got a network security group that's attached to a subnet, or you've got a network security group that's attached to an IP address. By default, you're not monitoring the logs. What's going in and out of those NSGs? What's happening if they're locked? What's happening if it's allowed? What's going on? The only troubleshooting you can really do is to have a look at the rules and take a look manually. You can't really see what traffic is really going through the access control lists of the network security groups. So in order to do that at management group level, I've deployed an Azure policy called deploys NSG flow logs and traffic analytics to log analytics workspace before I'm demoing this. So that means that by default, all the network security groups that I've created as part of this demo all have NSG flow logs turned on and traffic analytics turned on, all to a central log analytics workspace. So if you're running something like Microsoft Sentinel, you would potentially set your network security group flow logs, go straight into Sentinel. But in this case, I'm just deploying it to a log analytics workspace that I've created just for this demo, but it's really useful to use Azure Policy as much as possible, especially when you're looking at multiple subscriptions and multiple users using this and creating things. You really want to be able to leverage Azure Policy as much as possible to make it so within your Azure environment. So first up, we're going to have a look at Network Insights. So we're in our Azure portal and we've got an issue, or we want to know at a very quick overview, what is the health looking of our network resources? You might think, oh, I'll go straight into Network Watcher and have a look. Yes, you can go into the individual tools and start having a look and troubleshooting that way. But the easiest way to really get a good grasp of what your network estate looks like is by taking a look at something called Network Insights. So let's take a look at that. So we'd go to Monitor, just as you would if you were troubleshooting and having a look at alerts. Within the overview blade, you will see something called Network Insights. So click on this. Within the Network Insights tab, you'll see services that are available, degraded, unavailable, unknown. So the resource health haven't received information, or it's just not supported. You can see alerts based on your network resources within time intervals. Here, I don't have any alerts configured, or else I would see some of them. You would see how your Azure firewalls, their resource health, Bastion instances, network interfaces, network security groups, public IPs, virtual networks, and 2 VPN gateways as well. And you can see the VPN health. So if you click on one of these, you can go in. So for example, the Azure firewall, we can go and see it's available and the resource down here. So that's my lab-firewall. So that was created as part of the Hub and Spoke playground mentioned earlier, running in the West Europe region. And I can see that network rules hits. And that will take me straight into the metrics. And then the count of those. So you can see yesterday there was really nothing. And today I'm getting, no, it was yesterday. But yesterday there was nothing. And then I created the Azure Firewall and then applied the Azure Firewall policy rule to it. And I can see now we're getting network rule hits as well. So we can go straight into the monitoring from that. We can go back into our network health and we can have a look and click on our Bastion. So we can see the CPU, the session count, and the used memory. So if we're having trouble with Azure Bastion, for example, we would be able to go into Network Insights, click on the Bastion, have a look at the one that's causing your issue, have a look at the health. You can see here that yesterday there was a health event. Your Bastion host is unavailable, and then it became available. I think that was just after I deployed it. But you can go in here and see the resource health all within the single pane of glass without having to go into Network Watcher and these resources and try and troubleshoot. So you might be wondering what these are here. So this is the ability to view dependencies, which alludes into the topology view of being able to go, well, here's your Bastion right there. Says your Bastion runs on a virtual machine scale set. And in the background, I believe this is managed for you by Microsoft. And I think that's standard, potentially the standard SKU with 2 scale units. Obviously, the Bastion has a public IP because that's how you connect to, and then a private IP as well. So you can go in here and view the dependencies across that. And then this one is detailed metrics, which is currently not available for this type of resource. But these are clickable buttons that you can click to go straight into your dependency and then your detailed metrics as well. So if we've had a look at our network health, so far so good. Let's click on connectivity. So this is where you can view your connectivity or your connection monitor information. So for example, I can go in here to virtual network and I can see that I've got a connection monitor set up connecting from spoke 1 to spoke 2 of my environment. The name is connection monitor and currently it has no reachability. So I can come here and I can see it's failing 100% of my checks. If I click on this, I can open up the resource. I can have a look at the hop type. So this is just one virtual network to another. And then I can also see if I click on the spoke, which is the source of my connection monitor. So spoke 1 to hub to spoke 2. I can click on spoke 1. I can go routes for the destination I'm missing in the virtual network gateway. Traffic is blocked during to the following. Deny all inbound, all outbound. So this immediately tells me that my connection monitor is failing because of a user-defined route that I have and potentially a DNS, a network security rule as well. And it 100% failed within the last 24 hours. So connectivity is really useful, especially if you've got multiple source and destinations going. We'll go into connection monitor later, and I'll have a look and show you what I've got set up for those connection monitors. But I wanted to give you a really high level insight of what the network insights can give you without having to go technically depth into the other tools, such as connection monitor or NSG flow logs. And then we'll go into our traffic as well. So this is where the flow logs and traffic analytics is enabled. I can see that I've got flow logs and traffic analytics enabled on my network security group that's in North Europe region, and two network security groups that are in the West Europe region, but none in my Australia East region. If I click on that, I can see the list of the network security groups. So VM1, VM2, set up VM NSG. I can see that flow log configuration is not configured and traffic analytics is configured. But if I click on West Europe 2, I can see that both flow logs and traffic analytics is configured. And the reason, even though they're going to the same storage account, the same log analytics workspace, the Azure policy is creating separate storage accounts for traffic analytics. The reason why Australia East is not enabled for me is mainly because that is currently sitting within the subscription where those resources are sitting is deployed into another management group where the traffic analytics and flow log policy is not deployed to. So that's why it's not configured. But again, to really understand the health of your estate and make sure that all the NSGs that have been network security groups that have been created by both yourself and other teams and users actually enabled for best practices and logging, network insights is a really good area to go into. The last bit I want to show you within the network insights is really about this up here. So useful links, network watcher, connection monitor will take you straight to those within the Azure portal, network watcher and connection monitor within the Azure portal. Diagnostic toolkits will take you through to Microsoft Learn documentation about diagnosing traffic filtering issues or identifying next hops. The idea of this is that you'll come into network insights, you'll have a look at an issue, and then you might go, oh, actually, I need to troubleshoot my VPN gateway, or I need to then capture packets on virtual machines. So that will take you straight into the documentation to do that if you haven't done it before. But really what I wanted to drill down is topology. So if we click on topology, we can see our state. So I can see a map with 4 geographics, Australia East. I can expand. I can see that within the Australia East region, I've got 2 VNets. I can expand that further, and that will take me straight to that VNet. I can close this down, and I can go back to the map, and I can go into my North and West Europe. You can see here that I've got a virtual network peering between North Europe and West Europe. So the hub is in West Europe, and then one of the spokes, spoke 03, is in North Europe, and that's paired between those two. And I can expand this and drill into it further. So you can see all your spokes, the location, the resource group. I can click on the resource. I can see the insights. I can set up connection monitor from here. I can see the virtual network details, whether or not flow logs is enabled, the total traffic that's been allowed or blocked, external connectivity between on public IP. Sorry, it should be on premises but with the S, but oh, something to keep in mind. But yeah, public IP addresses. So how many Azure public IPs do I have? External IP addresses talking to the ports retrieving traffic or sending to the internet, all from this single pane of glass. Then you can delve into more of the metrics with traffic analytics. Last hour, I've got no data to display, no flows. Let's have a look at bytes. No. And then connectivity, which is where you'd set up your connection monitor. The reason why there's no traffic here is more than likely I got the virtual machine started, but I haven't really done anything with them. But I like Topology view because you can easily come in here and start to have a look at how your environment is set up. Here's the peering I was talking about earlier, where you've got your hub, you've got your spoke, and then you've got another hub in the other region as well. And you can use this to really drill down into your networking infrastructure without having to go into the virtual network, into the resource groups. Have a look at all the resources and try and work your way up from there. So that's network insights, and that can be found within Azure Monitor, Overview, Network Insights, or you can, under the Network Insights pane here, you can just go and click on Networks, and that will take you there. So next up, we're going to go into the more technical monitoring and troubleshooting tools. And first up, we're going to have a look at the VPN troubleshoot option. So let's go into that. So we're in our Azure portal. We've just had a look at Network Insights, and we found something wrong with our VPN gateway or VPN connection. Someone's reporting an issue, or you might have just received an alert. Let's take a look at how we can troubleshoot that. So within the Azure portal, type in Network Watcher and open this up. So Azure Watcher is a regional service. It exists but within the region, mainly where your resources are. So by default, when you deploy a virtual network within, for example, West Europe, it will automatically create a network watcher within that context. So you might see virtual watcher RG resource groups that exists within that as a resource type of virtual watcher, network watcher, sorry. And network watcher is really used to help drive connectivity between your virtual network and the rest of the Azure monitoring and networking tools that you use. You can change the name of the resource group from Network Watcher RG to a custom resource group, and you can also change the Network Watcher name as well. I know that's a current pain point where your organization may have naming standards, but then Microsoft Azure will go and create resources such as the Network Watcher. As you can see here, it's Network Watcher _ region name. That may not necessarily align with organization best practices. The only way to really change it is to use infrastructure as code and deploy Network Watcher using Terraform or Bicep or ARM and specify the exact name that it needs to be in. But make sure you've deleted your current one first. So we're in our Network Watcher blade, and we want to have a look at troubleshooting our VPN gateway. So to do that, we'll go under Network Diagnostic Tools and we'll click on VPN Troubleshoot. So within here, you'll see a list of VPN gateways. If you select one, you can see the status. but you may not be able to see anything else. So in this example, because I needed data for this demo, I've already gone through and ran the troubleshooting, but you would go in here, you would select the VPN gateway that you want to troubleshoot. You would select a storage account. So the storage account is where the logs of the troubleshooting will go into. And then it will run, and that troubleshooting could take 5 to 10 minutes. So that's an automatic process by Azure to really go in the back end and check the VPN gateway. Is it getting a response from the source? Some of the routes looking okay? Just some basic real troubleshooting in there. As you can see, I've got two unhealthy gateways. So one is my lab gateway, which is sitting in Azure, and then one is my on-prem gateway, which is simulating the on-premises connection in the France Central region. So I've gone through and I've clicked on Start Troubleshooting. I've specified the storage account to put the diagnostic, and it's come back with some information. So if I click on Lab Gateway and then try and can't resize this any further, but I can see here the summary of the issue. Well, hopefully if I can zoom in, you might be able to see. No, failing today. But no connections have been created on the gateway across premises or virtual network to virtual network connection needs to be created, which is quite right. So if I go into my VPN gateway, and then I can see when it's last run as well. And I think the other one should be almost exactly the same. Yep. No connections have been created across premises or V2V network needs to be created. So it tells me that this gateway is essentially just sitting here, but it's not connected to anything. And that's why it's not working. So if I go in and find our gateway, not net gateway is this one. And then I go to connections, I can see that this virtual network gateway actually doesn't have a connection. So I can go in here and click add, and then I can set up a site-to-site VPN or a VNet to VNet migrate. So I go on premises and Azure. And the reason I'm doing VNet to VNet is because I'm not replicating a site to site. I'm just duplicating the same thing. And by connections are unidirectional, so usually only traffic will flow from the first virtual network gateway to the other, but you can do bi-directional connectivity as well, which is what I'm doing here. Go next. You can specify your first virtual network gateway. So example, on-prem to Azure, shared key. So this needs to be exactly the same across the both. It's a shared secret. Hello, Azure Spring Clean people. And then you can go in and set up the connection mode and the tags and then actually set up the connection. So as you can see, VPN Troubleshoot is really useful for having a look at your virtual network gateway. What is the state of it? What is the health? If I was to connect these up properly, the status trait, the troubleshooting state will then go to healthy if it all looks okay. But it's really useful to go through what is the action, what is the issue. No connections have been set up. It's pointed me into the right direction. So that's VPN troubleshoot. So we've got our VPN gateway sorted. They're all looking healthy now, theoretically. Now we want to monitor the connection between endpoints, whether it's an on-premises network, so an Azure Arc agent installed on a server or an endpoint device connecting through to Azure, whether or not you want to monitor that that's successful, or you want to monitor an AVD, so an Azure Virtual Desktop session host. Maybe you want to monitor it connecting to M365. this is when you can use Connection Monitor. So let's take a look at that. So we're in our Azure portal and we want to have a look at Connection Monitor. So one endpoint connection to another, is it working? Is it not working? How do we monitor that? Connection Monitor is a hidden gem in the Azure networking space because it allows you to really set up alerting proactively about how your network is performing, whether it's between Azure networks or from on-premises into Azure, and on-premises could be another cloud as well. So to do that, we go into the Network Watcher, and under the monitoring, we click on Connection Monitor. So within the Connection Monitor blade, you can see that I've got 2 connection monitors set up at the moment. So one is spoke 1 to spoke 2. And this is looking for a TCP connection for RDP, which is on port 3389. So that's failed. From here, I can also set up an alert. Let's have a look at why it failed. So if I click on checks failed, I can see that the destination between spoke 1 and spoke 2 is not reachable. So again, that's telling me that in this case, there's an issue with the defined routes between spoke 1 and spoke 2 not going through the hub properly. There's not routes going either way. So it's connecting to the hub, but it's not able to connect the spoke. I know that because this is my environment, but again, the hop description says the destination is not reachable. So that really tells you where to start looking. If I go into the connection monitor itself, I can go in and have a look at the time interval. What was it over the last 24 hours? Did it just stop working? I can click on, this, which is the resource here, this is essentially the exact same topology view that we had a look at in the Network Insights resource as well. So they all share the same backend data and UI system. It's not like the topology view from Network Insights is operating on a different UI or data. It's not. It's all working on the same data as well. We can close this and we can close this and we can go into our Office connectivity. So this is another connection monitor that I've got set up. And one of the things I wanted to really point out here is even though I've got 2 failed connection attempts here, if I go into Office connectivity and go into Office, if I have a look at the validate status code reason why it's failing, it will tell me that traffic from 10.13.1.4, which is one of my virtual networks, is blocked because of a network security rule of default all outbound issue. We can also see the connectivity between Office, account.office.net is blocked because the topology is incomplete, and DNS resolution errors as well. So I know one of the asks when looking at troubleshooting DNS and troubleshooting issues within the Azure environment is, what about DNS? If you go to google.co.nz or google.com, will it respond with the proper IP address? Is name resolution actually working? And yes, you can use Connection Monitor in order to monitor that connectivity as well. And it will tell you DNS resolution has failed because there's no DNS server configured to really point to this. And again, auth GP validations failed, traffic blocks, very much the same, but not all endpoints are actually failed. If we go into our Office, we can see the status, and we can see that over HTTP protocol, so that's port 80, we can see that actually our connectivity between the virtual network and agent.office.net has failed due to domain name resolution, but we can see that our connectivity to apc.dells.office.com has passed. So these are working. We can see that clientlog.portal.office.com is not working. And again, we can see the status codes. Validation failed. Domain name resolution. We can start to really track down where the issue is and what could be causing our issue. Ideally, everything would be passed. So green, once I've sorted this out, everything will be green, and then the connection monitor will still continue to work. And then you can go in here, set up an alert for percentage fail or probed fail, or the round trip time has become less than your ideal circumstance. So, for example, you might be connecting to an Office endpoint for an Azure Virtual Desktop session server, and you really want to connect to an Office endpoint in less than 500 milliseconds. Ideally, a lot less than that, but say 500 milliseconds is the most that your users can tolerate. That's when you'd start coming here and setting up a round trip time for that. You can also import tests from Network Performance Monitor as well. And you can migrate connection monitors. So the reason I point this out is there was an old connection monitor version or service. And so you can import, if you've got that currently set up, you can migrate that into the new and improved connection monitor. But if you go to the Get Started tab, it really shows you kind of what you can do here with the little thing, with the little diagram. You can click Create Connection Monitor. Let's set one up. So let's just say, let's do the Office website test. So we go website prod from Spoke One. It's Europe. We specify our source, our test configuration, and our destination. So we'll just type in a name called website test. We'll click on add sources. We can specify the subnets. So we're going to go from Spoke One. We're going to select this virtual machine, this endpoint. So Spoke One VM. I want to know that my Spoke One VM can access Google HTTP destination port 443. I want to test it every 30 seconds. I can do every minute, every 5 minutes, every 30 minutes. I can also set up a custom frequency as well. I can edit custom status. I can go my success threshold, checks failed, and under 10%, round trip time, 500 milliseconds. We can add in that. So what you can do here is you can set up connection monitor tests for TCP ports as well, which is how I had on the other one. So TCP 3389 and ICMP as well. So it's ping and ICMP traffics going through. And again, the same. We'll just leave that. And then I can specify our destination. Actually, where I was going to show you that you can set up it's in the destination actually. So this is our destination. So we will have external address of Google, but we can also leverage external addresses. So an external address from the M365 portal, Exchange Online, Planner, Sway, Dynamic, Oceania-based organizations, which seems to be very generic. I'm assuming that this may change depending on where you live. But yeah, like instead of having to really understand these external address endpoints from Microsoft delivered services, you can come in here, check a button, and add them. I'm just going to add our Google one. This is only a test, and then I can go add test group. Then I can go next. You can specify a login alerts workspace. To set up my logging to, I'm just going to go into my hub playground. I can create an alert. So back in the connection pane window, we could see create alert from that. So you can create an alert from an existing connection monitor quite easily, but you can also use this opportunity to create an alert here with an action group by just clicking on this checkbox, and then it will automatically add that in for you. Review and create, and then create. Very simple process to get the connection monitor set up and working. My format's invalid, but I was only just using this as a test anyway to show you how easy it is to configure and create connection monitor endpoint. But if you go in here, I can see the invalid format. A path is wrong. Actually, the format should really have been, I think it's just / because the path will be root for that website. But again, very easy. And I can just go through and create as many as you want. So some people will have connection monitor from one virtual network to another, especially in production. You may want a few connection monitors going from your production hub network to your spoke networks. Is connectivity to that hosted website working over 443, etc., etc. So that's connection monitor. Enough our connection monitors. We're aware that they're running and hoping that's going to capture a lot of the issues and trigger an alert when it happens. What if we need to go in and have a look a bit deeper? So say you've got a virtual network that's connected to a spoke, or even a virtual machine connecting to another virtual machine within the same subnet, but both virtual machines have a network security group attached to them. This is when you can start going into the network security group diagnostics. So let's delve into that. So we're back in our Azure portal, and we want to troubleshoot connectivity between two the virtual machines as an example. So what I'm going to do here is try and connect from spoke 1, so a virtual machine that I'm running in spoke 1 as a target source, to a destination of spoke 2, which is the VM running there. So to do that, let's take a look. I can't RDP to it at the moment. It's potentially a network security group log or issue. Where do I go to? So go back to the network watcher pane and then go into NSG diagnostics. So here we can see our target. So for example, our target virtual machine is going to be spoke 2. We're going to connect to it inbound on, going to enter in the IP addresses and then the port of 3389, and then we're going to run NSG diagnostics. So that could take a few minutes. while it goes through and does that. But I want to really show you what's happening and what the log format looks like for each network security group flow log that you've already got set up. How we can see here it's denied. But once you've set up your flow log, so your network security groups are logging into an Azure storage account, that then creates a whole bunch of logs. And the format is like this. So it's got the time, the system ID, the category, resource ID, operation name, properties, timestamp, destination port, everything you'd expect from logging through your traffic, right? And this is an example of what the logs look like. So you've got your records, it's network security group flow events. You've got your flows, your flow tuples, your rules. Does a whole bunch of calculations. You can see a whole bunch of information. So troubleshooting these rules by having a look at the logs, yes, it's possible, but you would have to go through the JSON files and arrange it and you potentially have a log reader. And yes, you can go and do that. So you can access these logs directly from the Azure storage account that your flow logs are getting sent to. But it's a lot of reading and it's quite complex. So one of the things we can do is go back and use our network security group diagnostics tool to kind of go source destination. Is there anything on the network security group preventing that access? That'll have a look. We can see that there's an NSG called spoke2 VM, which is applied to our spoke2 virtual network, which is our target resource. And we can see that that is denied all inbound. So that is the network security rule that could potentially be blocking us. So we want to go in here and go add network security group, network security rule, and then add in, allow 3389 from this port, for example. Allow VNet inbound should take, so keep in mind that this test that I'm doing at the moment wouldn't work anyway because there's no routes between my spoke 1 and spoke 2 via the hub at the moment. If I were to enable that, then the allow VNet inbound rule would take effect. So when you're talking about network security groups, one thing to keep in mind is by default, this is the rule set that you're looking at. So allow VNet inbound, allow Azure Virtual Network, Azure Load Balancer, and then deny all inbound that's not part of that virtual network. So allow VNet inbound allows you to talk to same resources that are on the same virtual network as you, but also the same virtual network that you're peered to. So for example, if you've got an Azure Virtual WAN and that has many different spokes and it's also connected on premises, as an example, those routes, the allow VNet inbound will allow you to connect to your Azure resources through the NSG by default. Depending on the security requirements, it could be recommended to add another rule, so deny all inbound rule again, with a priority of 100. And stop that, not 100, it'll be something higher, like 1,000. That will stop you from being able to connect into peered resources unless you explicitly add in a rule for those IP to IP traffic. So just keep that in mind that VNet peering does take effect when you're looking at the allow VNet inbound rule. We've kind of gone off traffic there, but can be a catch-all. But again, I like the Network Watch NSG diagnostic because it really does point you towards where the issue could be in relation to your network security rules without having to delve into those logs. But what if you wanted to have a look at the logs, but you didn't really want to go in and open up your favorite text editor and have a view of it? You could do that directly within the traffic analytics. So if you go to traffic analytics down here, we can go in and see our traffic visualization, very similar to what we saw in Network Insights. I'll go through this shortly soon, but we're going to go into try traffic analytics workbook. So if we go into here, we can see our time interview, the flow types. So for example, NSG and VNet flow logs, we're just going to go to NSG flow logs, our log analytics workspace, the subscriptions that we have, the resource groups that we have, and a time interval. So for example, the last 24 hours. So I'm just going to cut this down to 12 hours. So this workbook allows us to bring in the information that's in those logs, stored in that security, in the Azure storage account, and really start having a look at what's your inbound, what's your outbound traffic, what resources talking to what are your top blocked NSG hits? Today is not the demigod's day. Traffic distribution across our resources. Our NSG and ECHL hits to access control list hits. Environment. And our ports and network applications. So this workbook, if it actually loads earlier for me, here it is. Actually gives you a really good, clear understanding of what's happening in your virtual network environment. So we can see that according to the IP traffic log collection, there's been 65,000 flows, and our frequent talkers, our total talking pair is between, as spoke one's obviously very busy. Spoke 2, 3, we can see what they're talking to. Potentially the top malicious, obviously spoke 1 VM is obviously doing something that it potentially shouldn't be. These are just stock standard VMs I've just kind of left there to filter and generate traffic. But as you can kind of see, total inbound, anything blocked, allowed outbound. It really starts to bring your environment into life. So traffic analytics, the traffic analytics workbook is another good place when you're starting to really start digging into those network security group diagnostics. Another thing to have a look at is IP flow verify. So IP flow verify will check if a packet is allowed or denied from virtual network based on the 5 tuple information. So you've got your virtual machine, spoke 1, you can connect your virtual interface, your local port. So again, instead of going through and going into the NSG diagnostics and then specifying your source and target destination ports, you can also come into IP flow verify and go the remote IP address. The local port is 3389. The remote port is 3389. Instead of just having a look at the logs, this will actually go through and do a lot more verified checking. It'll also have a look at the routes for you as well. So let me just grab that virtual machine IP address for bespoke VM2. I should have actually set up all of this beforehand, but click on verify IP flow. This should fail. So a lot of this is really in the hands that you have access to, all in the same single pane of glass. Very, very useful. Access denied. So it's gone in and said deny or inbound again. So IP flow verified along with the NSG diagnostics. Very, very useful. So we're nearing the high level view of the network monitoring tools available to us. One of the last things I want to show you is connection troubleshoot and packet capture. So let's dig into that a bit now. It's a combination of a lot of the tools that we've started to already use. So IP flow verify, NSG diagnostics, some of the workbooks we've had a look at as well, but this will go through and do a whole lot of the automation and checking for you using underlying Microsoft Azure managed services in order to do that. Let's take a look at that. So let's take a look. We're back in our network watcher again. Let's take a look at VPN troubleshoot, which we've already gone through. So I mean packet capture. Today is not the day. So within the packet capture pane of Network Watcher, what we can do is really Wireshark as a service. So we can click on add. We can configure our target endpoint. So it's either going to be a virtual machine scale set or a virtual machine. We can click on our target instance. So again, I'm just going to pick with Spoke VM2. We can enter in our packet capture name, our capture location. So it's stored in an Azure storage account. Any filtering we want to do, and we can start packet capturing on that instance itself. We can do filtering based on TCP, UDP port, IP address, local, remote, and we can click start packet capture. And what that's going to do is that's going to trigger the installation of the packet capture agent or extension on that virtual machine, and then start a packet capture. Very useful if you're trying to troubleshoot something more locally on that virtual machine. So for example, if you're running a website that's hosted on the virtual machine endpoint and it's published locally through 443, but you want to make sure that you can access it externally because maybe it's having problems, or maybe it's the domain controller that users and computers can't auth to. What you can do is you can use the packet capture to really delve into the virtual machine and the packets that it's really doing, that's running through, without having to go and install something like Wireshark and then maintain the version and things like that. That's going through the deployment there. So we'll just leave that. But next thing is connection troubleshoot. So within, let's go back here. I actually should be able to see this start to pop up. We'll come back to the packet capture later. But within the connection troubleshoot pane, Network Watcher really provides you the capability to check TCP or ICMP, so paying connections from virtual machines, application gateways, or bastion hosts to a VM or an FQDN IP address, URL, that kind of thing. So we can set our source type. So example, we're going to select our source type as a bastion host, and we're going to use the lab bastion instance, and our destination is going to be Spoke 01 VM. So what I'm really saying here is I want to connect to the bastion instance that's within my hub network, and I want to be able to RDP to the Spoke 1 VM. Can I do it? There's an issue. Help me find out where the problem is. I can specify an IP version, whether it's IPv4 or IPv6. Microsoft's really doing a great job trying to get in IPv6 within Microsoft Azure. There is worldwide government clauses to get a lot of IPv6 functionality into the cloud environments, both across the board of Azure, AWS, etc., by 2025. So a lot of the services like public IPs, for example, can be dual stack. Well, they'll have an IPv6 endpoint, and they'll also be able to have an IPv4 endpoint as well. IPv6 addresses don't cost, they're free. So something to keep in mind as well. But in this case, we're just going to leave the preferred IP version as both. I know we're not using IPv6 in here, but just select it. We're going to select TCP. We're going to select the destination port as 3389. The source port is not necessarily going to be the same. So it really depends on the type of system and application service running on it. The source port could be dynamic. So it could be arranged like in the 65,000s, dynamically created by your application, but the endpoint that it's connecting to, so example 443 or 3389, that port is going to be the same, but the source port is just going to be one that's available and open on that computer as you connect to it. Sometimes they're the same as the destination port, sometimes they're not, really depends. Diagnostic tests, we're just going to do a connectivity test. So let's click Run Diagnostic Test. And that's going to go and run that check for us. While that runs, if I go away from this pane, it will probably clear our troubleshooting. So we'll wait for this to complete. And it looks like it's completed. So if we go down, we can see that a connectivity test has been successful. We can reach the Spoke 01 VM from our Bastion host, which is in our hub network, with an average latency of 2 milliseconds, the highest being 7, between our Bastion and our Spoke VM. So that means that we can connect to our Bastion network, Bastion instance, and then use that to RDP into our virtual machine successfully from the hub network, which is great. So from the hub network, we know we can now connect to our Spoke VM that's not connected on Spoke network. There's just no user-defined routes connecting the Spoke networks to each other to be able to communicate to each other. But we know that within our testing, we can go from our Bastion host, which is on the hub, to our Spoke 1 VM as well. We can also change this to ICMP, and we can just do an ICMP test as well. Now let's go back to our packet capture. We can see that we've now got a packet capture that is on our Spoke 2 VM. We can see the bytes, and the status is loading, and our storage location, and our timeout interval. I believe that's in seconds, so let's take a look. Computers on this go slow. But depending on the time limit, yeah, it's 18 seconds, so that's 5 hours. So this will do a packet capture for 5 hours based on the default. I'm going to, and now it's running. But just keep in mind that I skipped over it before, but yeah, really the maximum limit of the set limit of your packet capture as well. So that will run for the next 5 hours. But then once that's done, we can download that packet capture from our storage account directly. If you've made it this far, thank you. The demo gods haven't been as helpful today as they were this morning when I was going through and testing it, but hopefully it's given you enough of an idea about the capabilities built into the Azure networking monitoring solutions to really point you in the right direction. Network Watcher is your best place to go to start really troubleshooting a lot of the issues you're experiencing around routing and network security groups. But Network Insights as part of Azure Monitor is really helpful to have a look at and get a really good understanding of what your networking landscape looks like. Connection monitor Connection monitors really useful for proactive alerting across your networking landscape as well to determine if things are running appropriately, what issues are happening. Very useful to set up ahead of time before you get that call from your user saying there's a problem. What's the performance like between these virtual networks? What's the performance like from on-premises into Azure? Connection Monitor can really help you. But hopefully you've gained enough of a high-level understanding to the tools available to you, and have a great rest of Azure Spring Clean 2024. See you.